Okay. So these things get answered really quickly. So like this guy, the right boy. Says, let's say the unmarked side is y, since y is the same value for both triangles. Yes, these are so much easier to do over video. The issue is that sometimes they're like a little too hard to do well in this like x-type radius fashion. Okay, well, I've done a little RStudio. Let's see. Okay. Like, if this is too hard for me to answer in 15 minutes, I won't even do it usually. Because I can't make the video, make sure it's like okay, and then post it before someone hit 2 or 3 people have answered the question. So I have to do them, they have to be pretty easy for me to do them in my normal format. So it says that there are 2 people watching, but I think they're both me. If anyone does come into here, please like say something in the chat. The bulk of I found that 52% of news about Twitter users get at least some news on Twitter. Okay, the standard error for this estimate was 2.54. Okay. Here's one of the sample proportion. Identify each of the following statements as true or false. Provide an explanation just for your answer. The data provides statistically significant evidence that more than half of the U.S. adult Twitter users get some news. 0.5. Okay, so this is the z-test. Okay, if we want to reduce the standard error of the estimate, we should collect less data. That's not right, obviously. Actually, I don't even want to do this. I hate statistics. Okay. There we go. Yeah, inequalities suck. Well, let's look and see. Sarah wishes to save no less than $1,500 in 12 months. If she saved $300 in the first 4 months, what is the least possible average amount that she must save in the remaining 8 months? This is like not algebra. This is some weird algebra application, and it's no wonder that people are confused. Like, this is a terrible question. You get these questions when you're in school, and you're like, what does this have to do with what we've been studying? You know, I don't like this one at all. Blah, 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 blah. And it's like, I don't even know how this teacher wants me to answer this. That's, okay. Right, so they want something in the form of an inequality. So it should be something like 300 plus 4 times x needs to be less than 1,500, right? Like it's a linear model. And I don't know why this really needs to be an inequality. Maybe I guess it's just relevant because that's what they're learning right now. Okay, so we've got a snapshot of this. All right, let me tell you, boy, I'm solving this thing. This is my first one, so. Hopefully it hasn't been answered. I was just sitting there running my mouth for a second. Okay. Oh. We only need one of the links. So that's the link. I'm going to comment this, and I just want to do a quick refresh to see if someone has already answered the question. Someone has already answered the question. Whatever, I'm just going to do it. All right, so this is basically what I do. I'll come over into Sketchbook, and then I add an image of this screenshot that I've just taken. And that comes in here. And this I just put in the window in order to remind myself of the question while I'm doing the problem. And so this says Sarah wishes to save no less than $1,500 in 12 months. So she wants to save a total of $1,500. Let's put the right color here. She wants to save a total of $1,500. So let's say the amount saved is going to be $300 for the first 4 months. And then out of 12 months, if she has saved $300, I'm sorry, she saved $300, but it's out of the first 4 months. There are only 8 months left. Okay, that's the first thing to realize. So we need this to be X amount times the 8 remaining months. Okay. All right. So in the 0th month, she saved $300, right? According to this model, it's really the 4th, but we're going to start from the 4th. So the end of our first month will be the end of the 5th month. Okay. I know that's kind of hard to understand. It wasn't explained very well. But this is going to be greater than or equal to 1,500. And this is just why they want you to use an inequality, because she wants to at least save that much. So let's make this look a little nicer, and I'll try to explain what I've done. I'm going to put the 8 in front of the x because that's the nice way we usually write it. It's just an aesthetic only thing, and I'm allowed to do that because of the commutative property. Okay, so at the beginning of the this like saving period where she's trying to figure out how much she has to save each month, she's already saved 300. This is at the end of the 4th month, right? Out of 12 months total. So we're going to start counting with our model from that point. Okay, so she has 8 months left, and we want to know how much she needs to save per month. So 8 times however much that is going to be how much she'll save over those 8 months. And then we add in this original $300, and that's got to be greater than her goal of $1,500. So this is what this says, okay? And we can solve this just like an equality. We have to be careful if we are to multiply or divide by a negative number, and everyone knows that, right? You guys know that. So just keep that in mind when you're doing this, and you won't make any mistakes. Actually, you probably will make some mistakes. That's totally normal, right? But it's good to make those mistakes in the homework and in the classroom if you can, not on your test. That's basically our goal, all right? Okay, and hopefully not live on the internet in front of a bunch of strangers. Well, currently no strangers. Hopefully the guy who posted, or the person who posted this, I shouldn't assume, will come back. Okay, so we're solving. So what did I do? I set up my inequality, and now I'm solving for x. Minus 300 minus 300, 8x over 8, 12 over 8. And then we've solved for x, we just got to simplify. So there is a factor of 4 in 12. I can see that immediately. So I'm going to reduce this to 300. And there's 4 and 2 are the factors of 8. Okay, so this is going to reduce to 300 over 2. But this is equal to half of 300, which is 150. Okay, so x must be greater than 150. And we can go, check this. We just plug our 150 in there and see if she'll make at least $1,500, Sarah. So 300 plus 8 times the x that we figured, okay? And let's see what this equals. This equals 8 times 150, so we're going to get 300 plus 8 times 100 is 800, and 8 times 50 is 400, so 800 plus 400 is 1,200. And then 300 plus 1,200 is 150, or 1,500, which is at least 1,500. So this is a solution. And if you think about it, like as x increases, it's only going to be more, so that's what we were looking for. Okay, person who apparently never came in the room, That's your problem solved. Solved it. Yeah. Boom. All right, I'm gonna hit refresh because all that stuff could be stale. I don't know if it's popping in the subreddit tonight or not. So for some reason, there's always 3 comments. Oh, calculus. Okay, I've been studying calculus, so any idea on how to prove algebraically without substitution? I know the limit doesn't exist, I just can't show it. All right. Let's see if the limit exists here. Any idea on how to prove algebra? Oh, I just read that. Okay. So we have a thing. Yeah, usually I don't go after the tough ones. I'd probably have to think on this for a while. Why should the limit not exist? I guess we could use a log rule. But I don't know if that moves through the limit linearly. Okay, see, now like I have to decide right away if I want to do this problem, because someone will answer it soon. I don't think I want to spend time on this. Discrete mathematics, propositional equivalency. I've been tutoring this a lot lately, and I don't know, discrete math class just seems like this like grab bag of a class that doesn't really help you with doing anything in the future. Verify the following using laws and identities. Okay, so P implies Q and Q or P. I don't even know what the symbol is. Oh, I see what they're doing. I feel like there should be a whole other side to this thing. I'm gonna keep this up and come back to it because I think someone else will come in who's smarter than me. Okay. How is Z equal to 24? This has a comment, so that's probably done already. Yeah, looks like it. Similar polygons. Cool. I'm reading a biography on Donald Coxeter right now. Coxeter, I don't know how to say his name actually. He's a very famous geometer, which I find interesting. He did proof on this one later in life, or not on this specific problem, but like circles tangent to each other, 4 circles tangent to each other, always produce a second set of 4 circles tangent to each other is the theorem, I believe, which I guess ended up being important for data science somehow. Write an equation of 5 circles that will produce this image, where the inner 6 circles are the same size and tangent to each other and to the larger outer circle. This is interesting. Grade 9 Algebra 2. All right, so what do we know? What do we know here? Let's draw this up. Why not? This is interesting. So that is our image. Write an equation of 5 circles that will produce this image. So this is 1, 2, 3, 4, 5, 6. This is 7 circles. So I really don't know how to write that up for 5 circles, but I don't know, let's see if I can do this. So we are going to insert an image, and here's our screenshot. Oh, I should tell them that I'm solving it. And I'm going to scale this a little bit because we don't need it to be. Actually, I'll just use this. Okay. And like if I do this method of saying, hey, all right, there it is. Tell your friends, kids. Okay. So, all right, here we go. So we have to make the equation of, it said 5 circles. I'm not going to do 5. I'm going to do more than 5 because I want to. I want to do it like it is on this picture. Okay. So here's a little thing. I'm going to draw some lines on this. This is Sketchbook, which is a really cool tool that I use for tutoring and things. All right, that looks kind of like the center. So from here to here is the radius. And then it looks like, I got it pretty close. We'll call this, let's just mark that down. I'm not sure what the relationship with that link will be. But that is the radius of another circle, which is important. And then we also need to care about these circles, so they don't touch at their center. It doesn't want me to put these too close. All right, so let's record this radius. I'm trying to figure out the relationship to these. Okay. Yeah. So we can draw the first circle, where we can make the equation for the outer circle really easily. That is actually going to help us anyway. So our general equation for a circle is x minus h squared plus y minus k squared equal to r squared. So let's give this radius here, let's call that r. This matters because h and k are the center of the circle, and r is the radius of the circle. Okay, so we're calling this at the origin. Now let's think about the other circles. I don't know if I can solve this actually. Well, he hasn't come into the chat anyway, so who cares? No, nobody is watching. We're just going to mess with this. Now, I know that the radii, or I should say the center, will fall on a radius of this thing. And I know that this should be split up into 1, 2, 3, 4, 5, 6 even slices, so to speak. Okay, so let's call the first one due north. So its x-coordinate is going to be 0. So I guess if I were to select this, and move it, it would be something like this, actually. Okay. Oh, that looks terrible. Anyway, this is straight up, so the center is going to be here. So it's going to be something x squared, h will be 0, plus y minus k squared equal to, so not quite r, actually. It needs to take up the same angle. So the radius of these will be on the point of another circle. Draw that for GWiz information. Let's see if it helps. This tool is really handy. All right. I use this a lot. Okay, so we can see that. This is going to fall onto another circle. I think this might take too long. At least this is kind of an honest, like, look at how this actually works for me. I spend a lot of time looking for a problem that doesn't take too long. Okay, here's an easy one. Somebody's probably already answered it. Oh, dang. Oh, that's not bad, actually. That's just a quick, easy concept problem. Can't figure out 2 and 4 through 6. I probably got assigned 2 and 4 through 6. Where are we at? There we go. Bird starts flying up from the grass in a park and climbs at a steady rate of 0.5 meters per second. Its height h in meters after t seconds is given by h equals 0.5 t. Equation h equals negative 4.9 t squared plus 40t plus 3 models the height in meters of a baseball 2 seconds after it's hit. Oh, this is macabre. Find the time it takes for the ball and the bird to reach the same height. Okay. So we have a linear model for the bird and a quadratic model for the baseball, and we got to find the intersection. So let's try it. So let's go boom. Actually, first let's see if this is waste of time. Yeah. Frustrating. All right, this might be bust. Let's try. Okay, let's try calculus again. I should go back and tell that other guy I'm not working on this problem anymore. How do I delete? Cancel? Delete comment. All right. Okay, so can't insert a point. Does this mean the whole graph is a minimum point? No, it doesn't. Can insert a point. Can I therefore find out? Okay. So hopefully this guy comes into the deal, but maybe I should say what time it starts at. I don't know. He'll figure it out. He'll figure it out if he wants to. We've already got 5 comments here. So these are good questions, though. Okay, friend, you're not here. I want to help you with this, so I'm going to try and do my best. I don't know how you're going to find this when you actually come to look at my video. I may be on to another problem. If you come in, just post something in the chat. All right, so you have a function here. It's 3x squared minus 2x. Okay, and so we know that there's a 0 here, and there is a 0 at 2/3. So let's call this 2/3. Okay, and I also know this is a parabola, and that my minimum is at 1/3, which is going to be 3. Actually, it'd be okay. So this is 6x minus 2, which is 1/3. So 1/3 gives us 1/9 times 3 is 1/3 minus 2/3, and that is negative 1/3. So here is negative 1/3. So this is the minimum. And so we get something like this. And so this should be smooth, right? There's no parabola tool on Sketchbook, so I can't do that. But what we can see here is that as this is f of x, okay, that's important to note, f of x. As we're going from left to right, so left to right, okay, what is happening on the y direction is we're going down, 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 down. We're going down, down, decreasing, 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 decreasing. Suddenly there's a turning point, okay? And from here we're going up, 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 okay? And what you can see here is that this turning point where we go from decreasing to increasing is the minimum. And I've sketched a little tangent, actually. Let me do a different color. Let's show all the whiz-bang features of SketchUp or Sketchbook or whatever this thing's called. Okay, so what does it say? There we go. I guess it doesn't really matter, it's just a sketch. We don't want that. Let that. Make it loud. All right. So this point here is where your slope is equal to 0. There's 0 rise over every run. No matter how far you go to the right and left, it doesn't go up or down. Okay, the tangent line I'm talking about here. So that means that at that point, f prime of x equals 0. Okay, and the x's that make this occur are of particular interest to us. Okay, that will help us find what the y value of our vertex is. All right. So we are in search of a particular x that will make f prime of x equal to 0. And the way that we can do that is we take what you've actually correctly found, 6x minus 2. This is f prime. And so we want to know what x makes this equal to 0. We can then set it to 0 and then ask, right? This is what we learned in algebra. And so I'll transpose the 2 and then divide by the 6. And I get x equals 1/3. X equals 1/3. Okay, what does this mean? This is the point that minimizes f of x. This is the point where the rate of change of f of x, f prime of x, dy dx, whatever you want to call it, the derivative of the first one, okay? Our first order derivative. This x value makes that equal to 0. So that is our turning point that we were talking about here. That's a turning point. And this is something that we can use to minimize and maximize all derivatives. Now, somebody else gave an answer which was not wrong per se, but what they said was that these places where your derivative is equal to 0, you have a min or a max. But that's not always true, actually. Sometimes you just have a critical point. And beyond that, the place where your derivative is undefined is also a critical point. So it's important to remember those things. Setting it equal to 0 is not always going to work unless you're talking about like a polynomial or something, okay? Rational functions and those kinds are going to be different. So here we have a critical point, okay? This is the root of f prime of x equal to 0. That's how we found it. Now, if we want to find the value, the y value of f of x at that point, we can just plug this back into f of x. That'll tell us the point, this particular one. I already found it. It was 1/3 negative 1/3. Okay, that is our minimum, which we'll prove in a second. Okay, now you did the second derivative of this one, and you found that f double prime of x is equal to 6, which is a constant. You cannot plug in 0 for this, or you cannot plug in x for this, right? And I think what you were thinking is that you should evaluate it at 0, and what we can see here is that we want to set it equal to 0. But what the second derivative tells you is the rate of change of the first derivative, right? So if the first derivative says, hey, I'm positive, the function is increasing. The second derivative says, hey, I'm positive, it's increasing at an increasing amount, or negative would be increasing at a decreasing amount, maybe. So basically right here, the function is becoming more negative, but the derivative is becoming more positive, right? The slope is negative, but then here the slope is 0, and then now it's positive. That's a linear thing. That's 6x minus 2. But let's graph 6x minus 2. Okay, here's minus 2, and there's a positive slope of 6. We have a line. We have a line here. And the slope of this is constant. It is always positive. Okay. So what we can do is we can look at the third derivative, and we get this. So we can say, at the point x equals 1/3, our first derivative is 0. Okay, so there's a critical point there. Now we can go here to our second derivative, and we can say, what is 1/3 here? Well, it's positive. So our slope is increasing just as it's 0, which means if it was increasing, it had to reach a minimum, right? It's going on the left side of this point 1/3. Oops. 1/3. The slope is 0. So to the left of it, it was less than 0. To the right of it is greater than 0. So when the slope goes from negative, negative, negative to 0 to positive, that corresponds to a minimum value. You had a local or an absolute minimum there. And this is called the second derivative test. So the first and second derivative tests are what you're doing here. This person never came into the chat, which is just as good because it's not that great of a lesson. So let's see. Let's go back at it. All right, there you are. I've done it. I did a thing for you. I hope you saw it. $16 minutes ago. Ugh, was I talking for that long? This has been a miserable failure of an experiment. Okay. Question 31. Oh. We're factoring. Man, this is an interesting question, I guess. These questions haven't been that bad. Man, I'm really not sure what is going on over there. His work doesn't, or this person's work, I should say, doesn't really mean much to me. All right. So far, nobody has been posting. I'm going to get one of those, like, you're doing this too much. Post in a second, hopefully. All right. If you are watching this, say something. Okay, so I'm going to copy this down. So we have 8x squared a plus 138x a y and negative 440 y squared a. Oh, you came in the chat. So say hello. You're my first ever person. I need to know that you are up to speed with us right now. I'm going to keep working while you say hello. So the idea here is that all of these things are multiplied together in these terms here. Okay. And what that means is we can factor them. And so what we need to do is we need to find out what is the greatest common factor between all of them. And generally speaking, I just start checking, right? So I see there's a coefficient in front of all of these. Okay, there's numbers in front of all of these. So I'm going to start factoring out a 2. It looks like all of these are even numbers. So this goes down to 4, so it's got another 2 in it. Okay, so this is going to be 2 times 4x squared a plus 1. This will be 50 plus 15 is 65 plus 4 is 69. Okay, and so that would be 120 plus 18. Okay, so that's factored correctly. A y minus 220 y squared a. All right, and then so I would do it again. I would try to see if I could pull out another 2. But actually, it doesn't look like it, right? The 69 is not even. So this only has factors of 2 and 2. So the coefficients are factored as much as we can. So now we have to find, similarly, another common factor in all of the other terms. And let's try x. Let's see if x is a common factor in all of them. Well, here's 2 x's. I have an x squared here, right? And then here is 1x. Oh, this one doesn't have an x. I can't factor an x. Okay, let's try the a. So this has an a, this has an a, and this has an a. Oh, sweet, I can factor out an a. Let's do it. So this becomes 2 times a, right? And then I get 4x squared plus 69xy minus 220y squared. I factored out my a, okay? And then lastly, we got to check the y. So we can't get a y there because this term doesn't have one. So this is factored, and we may actually be able to do a factorization of like a FOIL factorization. I don't know if they want us to do that. Let's see if I can figure it out real quick. So what we can do is we can treat this like a quadratic and just check and see if it will factor. This is a x squared, this is an x, and this has no x. So what I'm going to do is I'm going to factor it like it's this one. Let's see. And then we'll just check after and see if that works. Okay. So we can say x equals negative b plus or minus square root of b squared minus 4ac. All right. I'm just trying to figure out if there is a nice factor in here. There may not be. Over 2 times 4. Oops. Over 2a, which is equal to negative 69 plus or minus the square root of 69 squared minus 4 times negative 220 all over 2 times 4. And so let's see what we got. I'm going to use my calculator. Okay, so under the radical I get 8281, which is a perfect square. So we actually do have two factors. Okay, so we get negative 69 plus or minus 91 over 8. Now here this only has factors of 2, and none of these have factors of 2, so it doesn't look obvious that I can factor that real quick, or I can't simplify that. But let's do negative 69 plus 91 is 22 over 8, okay. So this is 22 over 8, which we can simplify, or negative 69 minus 91, which is negative 160 over 8, which we can definitely simplify, is going to be negative 20. And so this is 11 over 4. Okay. So this is 11 over 4. Okay, so what this means, if x equals those two things, that means x minus 11 over 4 and x plus 20. Solve this. And so this is not like an integer factorization, so I don't think I would even use this. It doesn't help you at all. So this is going to be the final answer here. And how do we check this? How do we check? Let's just distribute back that 2a, and you know how to do this. We'll multiply by 2a, 2a, and 2a, and we'll get what we originally had. So hopefully that solves the problem for you. I don't know if my explanation was that great. I said, how do you factor out? You factor it out. And practice this. It will help. It'll make you a lot more confident. Let's see if you ever said anything in the chat room. Nope, you came. You left. Thank you for coming. It means a lot to me. All right, let's do another one. Sayonara. Okay, let's get rid of this. Oh, thank you, Ben, for posting in there. I'm typing to you. Yeah, you were done. And I wasn't sure that I was done. Like I went through and I tried to factor it, and I just saw that it wasn't a nice thing to factor. So I knew I was done after that. Good work, really good work. These are not easy problems, and it takes time. Okay, so let's see. keep, subscribe, please, if you're still here. That'll help me out. I'm just trying to get my subscriber count and hours up. And you can always go to the Glauxy subreddit, GLAUX _ I think, actually, and post questions there. I just started it yesterday. Is there an answer key somewhere online for this? Okay, bro. Here, let me. This is great. This is great. Oh man, this is so funny. I hated homework, and the internet wasn't what it is today when I was in high school. If it were, I probably would have done more of my homework, but it wasn't easy to cheat back then, so I just really didn't do it. All right, here we go. So we're gonna do this like one at a time. All right, so this is -3 root 12 r. -3 root 12 r. All right, so we are just simplifying expressions. Simplify expressions. Assume all variables are positive. Okay, that's a nice assumption. That makes things easier for us. So basically what we can do is we can factor anything under the radical. So we get -3 times the square root of 12, which is 2 times 2 times 3, right? 2 times 3 is 6, times another 2 is 12. So if you don't believe that, post something in the comments, right? Or like say something in the chat, and I'll explain it more, okay? You can say anything, just say stop or help or whatever, I don't care. All right, so -3 times the square root of 2 times 2 times 3. Okay, since 2 times 2 times 3 is equal to 12, these things are equal, okay? And there are two factors of this number, and since I'm taking the square root, that means that this is a perfect square under the square root, so I can pull that out, okay? Now, I'm not going to pull out 4. 2 times 2 is 4. 4 is the square root, so I only want to take out the square root of that. So that's going to be -3 times 2, okay? And the square root, I took out the square root of this number, so both of those are gone, and I'm left with a 3, okay? That is how a square root works, right? The square root of 4 is equal to 2. So that's what's outside now. I just took it out. And this is as simple as it goes. You just want to make sure you give the actual final product here. So 3 times 2 is 6. So -3 times 2 is 6. And then this is times 3r. And that's as simple as it gets. It seems a lot harder than it is. Not that hard. All right, so here we've got some exponent rules. Can I make this bigger? Yeah, there we go. We've got 4 to the 3 halves times 4 to the 5 halves. 4 to the 3 halves times 4 to the 5 halves. 4 to the 3 halves times 4 to the 5 halves. Now we have an exponent rule. It says when you have a number a raised to the b times another number of the same base a raised to any number c, okay? You just add those two. So we just put it on one base, and this becomes b plus c, okay? So how does that work with our example? Here we have a and a. Our bases are the same. So we can put it on one base, but then we just add the exponents. Add the exponents. So we get 3 halves plus 5 halves. Now a lot of you are reaching for your calculators. But just wait, what is 3 halves plus 5 halves? Well, it's 3 plus 5 over 2, which is 10. So it's 8 over 2, so 8 over 2. And we can simplify this. This is just equal to 4 to the 4. And I don't know if they want us to actually do this. This would be 4 times 4 is 16, times 4 is 64, times 4 is 256. This is 256. Either this or this will be the answer. So one of these two is what they want. I personally prefer that, the 4 to the 4 here. I think it kind of label, honestly, I would even say 2 to the 8, right? Is the better expression of that, depending on what your context is. Okay, what else you got going for us? 27 to the 4/3 over 27 to the 2/3. 27 to the 4/3 over 27 to the 2/3. All right, so we have here an exponent rule that says if we have a to the b over a to the c, this is the same as a to the b minus c. And I hate to call these things a rule. If somebody comes in here and asks me a good question, I'll explain why it works this way. Come in here, ask why. I'm the only person in the chat, so it's like, no one's gonna ask. But if you were here and you did ask, I would give you a nice explanation. Otherwise, I'm gonna show you the application of the rule. Okay, so this is, here A is 27, right? And A is 27. So we can put it with one base and do B minus C. And B is 4/3 and C is 2/3. So this becomes 27 times 4/3 minus 2/3. So let's look at just that part on the side here. These two things are equal. What is 4/3 minus 2/3? Well, how do we add or subtract fractions? We just add or subtract the numerator, and this becomes 4 minus 2 over 3. Okay, so 4 minus 2 is 2, and put the whole thing over 3. So this is equal to 27 times 2/3. Now, we can simplify this further, actually. So 27 is 3 to the 3rd. So this is 3 to the 3rd, okay, raised to the 2/3. Right? And we know that when we have a to the b raised to the c, this is the same as a to the b times c. Okay, this is just one of those exponent rules which you guys have not asked me to explain. Ben Arp was in here. Thank you, Ben Arp. That was really sweet of you for coming into the live stream, my first live streamer. I'll remember you forever. So if A is 3 and B is also 3, okay, and C is 2/3, then this must mean that this is 3 to the 3 times 2/3. And 3 times 2/3 is just 2. So this is 3 squared, which you can write as 9. I prefer this one. I think that's simplified enough, but they probably actually want this. All right, so let's do big erase. I hope this person shows up because they're getting the whole homework done for them. Whole homework done for them. We're on number 4. Well, is this you? Is this your question in the chat? Give us a shout out. Say something to us. I'm solving your homework for you. All right. So we've got a squared squared. A squared squared over a to the 3/2 times b to the 1/2 times b. A to the 3/2 times b to the 1/2 times b. Okay. So we just wrote this down. I'm going to write a little exponent rule. If you ask me to explain this, I will explain it. Okay, but I'm just going to write the rule. So if we have, I'm not going to use a here, I'll use x. No, let's not use x, let's use k. So if we have a number k, right, raised to the base L, okay, and then we take that number and we raise it to another power. Let's call that m. So here we have a base, an exponent, and then we raise this whole number to another number, okay? Then we can just multiply the exponents, all right? And this is what we have here. This would be k, this would be L, and this would be m. So we are going to multiply those exponents. We're going to get a to the 2 times 2, which is 4, right? And then this is still going to be a over the 3/2 times b to the 1/2 times b, okay? Now we can simplify this denominator, but I think the easiest thing to pay attention to will be we have a base a in the numerator and a base a in the denominator. So we have another rule that says if you get something like, let's say, k to the L over k to the m. Now the bases here, k, are the same, okay? So that means that we can bring the numerator, bring the one of the denominator up to the numerator and subtract their exponents. So I'll get L minus M. All right. So here K is A, L is 4, and M is 3/2. So this will become A to the 4 minus 3/2 over B to the 1/2 times B. And then we know that 4 minus 3/2 is the same as 8/2, right? Minus 3/2. And I can show you how to do that if you're confused. Just let me know in the comments or let me know in the chat. And then 8/2 minus 3/2 is 8 minus 3 over 2. So this is A to the 5/2. Now this A is as simple as it gets so far, but we still got to deal with the denominator here. Our denominator is B to the 1/2 times B. Okay. Now let me throw one more little formula up. These are those exponent rules we're talking about. We have B to the, oh wait, we don't want that. Let's do it with some, let's use our K, L, and M. So if we have K to the L times K to the M, now in this case our B is the K, that's our base, then this becomes K times the sum of the exponents. We just add the exponents. When we multiply bases, we add exponents, all right? So in this case, we're going to copy down our A to the 5/2. This is going to be B to the 1/2 plus this exponent for this B. What is this here? This is, it's not written, but it's understood to be 1. This is actually raised to the 1. So we get B to the 1/2 plus 1, okay? And what is B to the 1/2 plus 1? That is 1/2 plus 2/2, which is 3/2. Okay, I would call this simplified enough here, but maybe they want to see actually A to the 5/2 times B to the negative 3/2. And you know, I'm not sure. I think I would report this one, but that's also equal, okay? All right, let's see. Let's do the next. That one was long. Oh, we got 3 watchers. Sweet. Say what's up in the chat. Say hello. Post a question or something. So at least tell me if you're following. All right, so this is 27 times 64 to the 2/3. All right. 27 times 64 to the 2/3. Okay, so this one is interesting. I think I'm going to factor this 27 and 64 real quick. So this is equal to 3. So 27 is 3 to the 3rd, right? And I know that because I've done it a lot. 64 is 8 times 8, which is 2 to the 3rd times 2 to the 3rd. This is 8, and this is 8, okay, raised to the 2/3. This part is equal to this part. You can check it later, or you can ask a question. Then I'm going to keep simplifying this. I'm going to say this is 3 to the 3rd times, now when we multiply two numbers with the same base, we add their exponents. So this is 2 to the 6th, and still everything is raised to the 2/3. But this is equal to, now this trick is slick. You take the denominator and you move it to the nook of the exponent, and then you drop down the numerator. And so I'm going to get the cubed root of 3 to the 3rd times 2 to the 6th raised to the 2. Okay? So we know that if we have a number raised to an exponent and then we square it, okay, we just multiply by the exponent. So this is going to be the cubed root of 3 to the 6th, and then I'm going to do, so that was 3 times 2, and I'm going to do 6 times 2, so this is going to be 2 to the 12. Okay, now I need the cubed root of all of this, the cubed root of all of this. So this is actually a perfect cube. It's 3 squared times 3 squared times 3 squared. So I'm going to bring out 3 squared. And this is a cubed root. I could just divide this by 3, right? Actually, maybe I'll write it that way. It'll be easier for everyone to see. So I'm going to undo that little trick I did with the bringing the denominator down, I can write the same thing as 3 times 6, or 3 to the 6th times 2 to the 12th to the 1/3. So this is the same as the cubed root. Okay, it's just a different way notationally to write that. Now you can see that I should multiply here by the exponents, and this will be equal to 3 to the 2 times 2 to the 4. So this is simplified, but we could probably make it even more. 3 squared is 9, and 2 to the 4th is 4, 8. 2 squared is 4, times 2 is 8, times 2 is 16. And then this is equal to 90 plus 54, which is 144. That makes sense because that's 12 squared. Okay, so this is the answer. And let's see, did anybody post any questions? No questions, okay. Well, thank you guys anyway for coming to watch my live stream. All right, so we did number 5. We're on to number 6 now. So this is 1 over 243 to the 1/5. So this is 1 over 243. And there are a lot of different ways to do these, guys. Don't get hung up on my little interpretation. All right, so this, we can say that this is the same as 1 to the 1/5 over 243 to the 1/5, which is equal to, 1 to the any power is just 1. And then this is going to be 243 to the 1/5. Okay, let's see if we can factor 243. Looks like it's got a 3 in it. So it's going to be 3 times 240 goes 81 times. Okay. And then this is going to be 3 times 9 squared, which is equal to 3 times 3 squared squared, which is equal to 3 times 3 to the 4th, which is equal to 3 to the 5th, okay? So this is equal to 243, right? So that means that we have 1 over 3 to the 5th times, or raised to the 1/5. And then so we multiply the exponents here, and we are left with 1/3. So fancy way to write 1/3, box this one, this is the one. All right, next we have it. Is it helpful? Is it helping? Somebody tell me if this is helping, please. All right, what's next? Okay, number 7. 25x to the 3/2 over 5x to the 1/2. (25x) to the 3/2 over x to the 1/2. Okay, so this is the same as 25 to the 3/2 times x to the 3/2 over x to the 1/2. Okay, then we can say that we have 25. 25 is 5 times 5, which is 5 squared. Okay, so this is 5 squared to the 3/2. And then we leave that x to the 3/2 for now, and that x to the 1/2 for now. And then if we have a base to an exponent raised to an exponent, we just multiply those exponents. And so we are going to get 5 times 2 times 3/2, which is 3. And then we're going to copy down our x to the 3/2 and x to the 1/2. Okay. And then we know that there's an exponent rule that says if you have a to the b over a to the c, here the bases a are the same, this is equal to a to the b minus c. So this is 5 to the 3 times x to the 3/2 minus 1/2. And how do we add fractions? We just add, or subtract in this case, the numerator, and leave that over the denominator. So that is going to be equal to, oh, so my friend's calling, tell him, live stream on YouTube. New phone, who dis? Boom. Okay, sorry. when I have tutoring clients, I don't text in front of them, but you guys are getting this homework for free. So, all right, so this becomes 5/3, so we're just subtracting the numerator. So 3 minus 1 is 2, over 2 gives us 1. So x to the 1 is just x. Okay. Now, what? I think this is our last one. Actually, maybe it's not. Oh, he wants the whole paper. Wow. Man, you got to cheat better, or you got to just do your homework. Another one here. Hopefully you don't get bored before the hard one. So this is 4x to the negative 1/2. And then 9x to the 1/2. All right. Okay, so we can keep this as, let's say, we'll do 4 to the negative 1/2, x to the negative 1/2, times 9 to the 1/2, x to the 1/2. This is here, I think. Let me check. Yeah. Okay. Now, this is the same as we want to bring the negative exponents to the denominator. So we're going to get 9x to the 1/2, and this is to the 1/2, and then 4 to the 1/2, x to the 1/2. Okay, and then we can see this cancels straight away. That just is gone. And then so 9 to the 1/2 is the same as the square root of 9. And 4 to the 1/2 is the same as the square root of 4. These are both perfect squares. So we're going to get 3/2. That is the final answer there. Box that guy. Okay. Now we've got 3 times the cubed root of 81 x to the 4th y squared. 81 x to the 4th y squared. Okay. All right. So let's see if we can simplify this. I said the cubed root is the same as raising this to the 1/3. So we'll just do that for now. I'm not sure if it'll help us. Then we've got 3. 3 is 3 times 27, which is 3 to the 3rd. So this is 3 times 3 to the 3rd, which is 3 to the 4th. And then we've got x to the 4th and y squared, and this is all to the 1/3. So we just multiply this exponents, right? Same rule as the last few problems. And this becomes 3 to the 4/3, x to the 4/3, y to the 2/3, okay? And then we can just disassociate this and take out the parentheses. This is going to be equal to 3 to the 1, right? 3 is equal to 3 to the 1 times 3 to the 4/3, and x to the 4/3, and y to the 2/3. So now we just add, these are the same base, so we add their exponents. And 1 plus 4/3 is the same as 3/3. That's just 1. 3/3 plus 4/3, which is 7/3. So this is 3 to the 7/3, x to the 4/3, y to the 2/3. All right, and box that one. That's your guy right there. Hopefully you can read this. My handwriting is not doing so pretty now. My hands are getting all crampy. I'm doing an entire homework. Okay. All right, same exact thing. These are just so tedious. Negative 5 times the cubed root of 5, negative 500 x to the 5th y third. Negative 5 times the cubed root of negative 500 x to the 5th y to the 3rd. All right, so we have a negative number under here, so we're going to get, I don't know, this must be algebra 2. Algebra, okay. You may not understand what I do on the second part here, but we'll talk about it. All right, this is equal to negative 5 times negative 500. Oh, this is a cubed root. We're good. Times x to the 5th times y to the 3rd, the 1/3. Okay, the cubed root is the same as raising it to the 1/3. So this is negative 5, and this is the factorization here is negative 1 times 500, right? But 500 is 2 times 250, which is 2 times 125. So 2 times 250, 2 times 125, and that is 5 times 5 is 25, times another 5 is 125, so that's 5 cubed. And x to the 5th, y to the 3rd. So I'm just going to do some eraser magic. 2 times 2 is 2 squared. And then these are all factors, so 5 to the 3rd, x to the 5th, y to the 3rd, and 1/3. Okay. Make it look like I did it all in one step. So the cubed root, we can just put this for each one. So the cubed root of negative 1 is actually negative 1. So this is negative 1 times negative 1 is 1, times negative 1 is negative 1. So it's a perfect cube. All right, and then 2 to the 2nd raised to the 1/3, we just multiply the exponents. Becomes 2 to the 2/3. And then 5 to the 3rd times, so raised to the 1/3, we just multiply the exponents and we get 5. 3 times 1/3 is 3 over 3, which is 1. And then x to the 5th raised to the 1/3 is x to the 5/3. And y to the 3rd raised to the 1/3 is y to the 1, which is just y. So negative 5 times negative 1, I'll put that up here. Negative 5 times negative 1 is just 5 to the 1, okay? Times 2 to the 2/3 times 5 times x to the 5/3 times y. And then we add the exponents here for the 5, and we get 5 squared times 2 to the 2/3 times x to the 5/3 times y. That's simple enough. There's nothing really you can do with that, and maybe they want you to write 25 there, but I doubt it. Okay. The frequency f in hertz at which a simple pendulum rocks back and forth is given by f equals 1 over 2 pi times the square root of g over L, where g is the strength of the gravitational field, which is constant near the surface of the Earth at the location of the pendulum, and L is the length of the pendulum. Okay, rewrite the formula so that it gives the length L of the pendulum in terms of g and f. Okay, so we're solving for L, essentially. So that was a long-winded way to say solve for L. Okay, so we're going to multiply both sides by 2 pi, and we'll get 2 pi f equal to the square root of g over L. And let's square both sides so we can get rid of this radical. So I'll get 2 squared pi squared f squared equals g over L. And then I want to solve for L, so I'm going to multiply both sides by L, and I will get L times 2 squared pi squared f squared equal to g. And then I'm going to divide by all this junk. So that I can get L by itself. So I will get L equal to, so this cancels, right? All that cancels. G over, let's call this 4. 2 squared is 4, pi squared, f squared. Ta-da! Final answer. Let's box it. Okay, and then use the equation found in part A to find the length of the pendulum to the nearest foot that has a frequency of 5.2 hertz. Okay. 0.52 hertz. So this is going to be, so the length is going to be equal to g divided by 4 pi squared 0.52 hertz. And this number you have to go look up. I don't even remember. It's like 1.17 times 10 to the 6th or something like that. I'm not going to look it up. You look that up and you put this all into your calculator, and the length should be measured in meters. Okay, that'll be your unit. But that's calculator work. I don't like numbers bigger than 4 or smaller than 1. All right, so whoever that was, let's see if you're still here. You're very welcome. I'm hoping this helps. If it's not helpful, you know, this is what I'm doing. I'm doing this. Subscribe, please. But if it's not helpful, just say something, you know, like ask a question. I'm going to turn my little thing up so I can hear you guys asking questions. But, you know, keep your head up, do your homework, and good question. Thank you. Well, try. Don't always just look for the answers. And go in my post history and look in the subreddit I just created. You can just ask me questions directly there. Okay, so I'm gonna do one more. I don't know how much steam I have left in me. If you subscribe to me and keep your notifications on, if you ever see me live streaming, come in here and ask me homework questions. You know, like you see how long it takes me to find questions. It's terrible. Hey, thank you. You're welcome. I'm glad it helped you. Really, ask me more questions. Tell your friends. They all have the same homework, right? Put them on the timestamp. Like, tell your people in your class. Save them the effort. Oh god, I don't even want to read. Every time I get mail, I don't want to read it because I'm afraid like I made someone angry or broke a rule or something. Okay. I don't know how to set up this problem to solve. 2 comments. All right. Oof, okay. Man, I have a friend who always does screenshots like this, and he's a really smart guy. But you're on a device that can do a screenshot. You know, just do Command-Shift-4, click and drag the area that you want to screenshot, and upload it as a file. You know, you went like way around the barrel to get this done. I'm not even going to try this because you are bad at screenshots. See, make me feel like a bad person. Now I'm going to do it. A dietitian is planning a meal of chicken. Does anyone see how ridiculous this is? A dietitian is planning a meal of chicken, rice, and peas for a patient. The patient needs the meal to contain 74.4 grams of carbohydrate, 30.8 grams of protein, and 4 grams of fat. The table below shows the number of grams of carbohydrate, protein, and fat in 100 grams of each food. Oh, okay, I see. Note the total is not 100 grams due to the water and fiber content of the food. How much of each food should be used so that the patient gets the nutrients, the needed nutrients? Look, I'm not even doing this. I can't read it all on one screen. It's just too much of a pain. All right, is there anything else that I want to do tonight? What's the difference between shell method and disk method? That's actually a good question. I don't want to do calculus tonight. Okay, this has been up for a while with 2 comments still. So they always put 2 comments right in there. Oh, right. Yeah, I looked at this and I would do it. Okay, let's try a different subreddit. So this one's good. For the last guy that was on here, if you are still watching, this is a good subreddit for you. I don't condone cheating exactly, except, you know, I think you should use all the resources out there and do the appropriate amount of work. Like, if you're working and you're in school, you just don't have time to teach yourself everything. Oh. Did I already look at this? Use the graph of the function f to answer the following questions. Find the open intervals on which f is concave. Okay. I really don't want to like look at badly formatted images if I can help it in my entire life. Oh man, there's so many people in here. This is the most people that's ever been in here. Do you guys have any questions? Whoever's watching, I don't know. I can't even see you. I don't even see your names. That's cool. That's all right. Thank you for coming and watching my ranting. I don't like probability or statistics. Integrals, do I want to do some integrals? Integral from, see, this is like, just take a picture of it. 0 to pi over 2. Okay, I'll do this one. So this is a definite integral. Oh, let me tell this dude what we're up to. You guys can see how much I agonize over these problems. I just want to find problems that I can do quickly. And hopefully, you know, I do like it when someone has tried it and shows me what they did so I can give you some feedback. Like I want to tell you not only how to do the problem, I want to tell you how to understand it so that you can do the next one, even if I'm not there. Okay, so this is for those who are taking Calculus 2, or actually, maybe you guys are at integrals if you started Calc 1 this semester. I don't think so, but okay, from 0 to pi over 2 of cosine x plus sine x dx. So okay, this is the same as evaluate. Well, we can just do it all in one step. So this is going to be the integral of cosine is sine, and the integral of sine is negative cosine. And this is going to be evaluated from 0 to pi over 2, right? That's our limits of integration. So we take sine of pi over 2 minus cosine of 0. Oh no, I'm sorry. Almost made a big mistake. Pi over 2 minus sine of 0 minus cosine of 0. All right, so the sine of pi over 2 is 1, and the cosine of pi over 2 is 0, and the sine of 0 is 0, and so minus and minus here we get a plus, the cosine of 0 is 1, so this equals 2. And hopefully that helps. I don't know if I actually explained anything. These like trig integrals, you gotta go look at those. You need to look at the proofs. You need to work with them, do the derivations yourself a few times, especially if you're like me. I can't memorize anything. I've done the derivative of tangent like 6 million times before it stuck, and then actually the derivative of secant is another one I did a bunch of times. All of those trig function derivatives and integrals, do them over and over and over again. Do the proof. Don't sit there and try to memorize them, because the proof just has like one trick for each of them, and like it's always the same trick for like an entire class of problems. So once you've seen the trick once, you'll be able to memorize them if you just do it through a couple of times, like in the corner of your paper. Oh, somebody answered this. God dang. That guy's never coming to watch. Oh, right. This subreddit doesn't post a bunch of comments needlessly by the automod. Well, I don't know if it's needless, but the automod doesn't post a bunch of comments. Integrals and calculus. I eventually got the answer for my mode. Yeah, why? I can't explain this. I was having a lot of trouble from this problem last and just ended up finding an example online similar enough to replace their numbers with mine, and I understood the steps themselves, like the math behind them, but I don't understand why at all they did it the way they did. The question was to evaluate the integral x equals 0 to x equals 1 of x minus x squared to the 1/2. Oh, yeah. Okay. So this is like, yeah, here he says, I ended up having u equals to this, x equals to this. I don't even know if I want to mess with this, honestly. This is too long of a question. Okay, let's try another subreddit. I might be jumping off here soon. If there is anyone left in the chat and you have a question, post it real quick, because my friend is texting me and calling me, and I want to chat with him because we haven't talked in a while. Anyone? Bueller? Okay, thank you. The few people that came and popped in and looked, it means a lot to me that it was helpful to you guys and that you came and asked a question. That's a brave thing, to ask a question in a public forum. So congratulations, good on you for trying. And please, if you see this later, subscribe, like, comment, and post questions. Go to that Glauxy GLAUX subreddit. Check my Reddit username. You'll find it in my post history. And keep up the learning, y'all.